Okay, so exponential functions have the following characteristics. Here's a general exponential function. Now there's two specific types of exponential functions which we'll talk about today, but go into more detail later on in this unit. That would be exponential, decay, and growth. So there are functions that are exponential that we don't classify as exponential growth or decay. Keep that in mind. This is the general format of an exponential function. So the first thing you need to know, in general, exponential functions are continuous and one-to-one. So I'm going to write down 2 to the x power on my calculator, and I'm going to graph it. So we want to understand, what does this mean? Continuous means that this will continue to go to the left and it will never stop. And again, as it goes up, it will also continue to move to the right, never stopping. So it's continuous from left to right. One-to-one defines it as a function. So we say something is one-to-one if it passes the vertical line test. Vertical line test says that every x value will have at most one y value. So if I did a vertical line test along this function, it would pass. That's the first concept. The second concept, many students from my previous class already remembered. The domain of all exponential functions is negative infinity to positive. There is a horizontal asymptote on all exponential functions, and this is assuming that we're not translating, we're not vertically shifting this up or down or to the left or right. So there is a horizontal asymptote, and it occurs on the x-axis, and the technical equation for that is all values along the x-axis have a y value of 0. The fourth one is talking about the range. So the range of these functions, you have two options for the range. If a's are positive, did I have this class, did I ask you to take out a separate piece of paper and you drew what was on the board? That's going to be very helpful. Take that out, please. Find the first two graphs where a was positive. There's 2 examples, and then there's 2 examples where a was negative. If a is positive, did you see something like this? You don't have to draw it if you already have it down, yes? Yeah. Okay, so if I asked you, what is the range of this function? The lowest value, again, we're not talking about this thing being shifted. The lowest value is 0, and there's no limit how high it goes. In both cases, it does not actually touch 0 or positive infinity. The second fact is if a is less than 0. Then we're getting something like this, or something like this. This is the one that students consistently get wrong, and I'm going to try to trick you on your checkpoint quiz. So if I asked you for, and I'm going to write down what the incorrect answer is, and then I'm going to cross it out. Most students are going to write it like this. That's the range. And although they picked out the right number and the right symbol, what's wrong about that? Right, so I'm going to cross it out and write negative infinity to 0. Two concepts left. I'm going to fit them up here. The next concept is the a value represents the y-intercept. And the last one is just a little more detailed. If you took y equals a times b to the x, and y equals a, and now I'm going to do the reciprocal of b, so 1 over b. These two functions, if you graphed them, would reflect across the y-axis. And at this level, I like that you understand it's the y-axis, but what is technically the equation for the y-axis? X equals 0. you're going to do me a favor. You're going to be totally honest because some of you maybe weren't here or you don't remember. When I ask you, I want you just to raise your hand. How many of you, if I gave you a graph yesterday, I said, in your mind, do the vertical line test, and I want you to tell me if it's a function. How many of you could have looked at the graphs in your mind in a vertical line test and said, yes, it's a function? Okay, and it's okay if you could. So that's the first one. How many of you remember from yesterday the domain is negative infinity to positive? Maybe about 50%. How many of you remember there was a horizontal asymptote at the x-axis? Again, about 50. And then again, if you saw these, I think you can identify them. But here, a's are greater than 0, less than 0. Not too hard of a concept. How many of you remember that a is the y-intercept? Only a couple of us. And then this one obviously is new, and this is a little more complicated. Flip to the next page, please. You are going to add an option D here, and we'll talk about that when we get there. So I'm going to draw an umbrella here. I know my umbrella is ugly. But this umbrella represents exponential functions. So within exponential function, you could have just general exponential functions, and then there's two types of specific ones. There's ones called exponential growth, and another one called exponential decay. So you could have an exponential function that's not growth or decay, okay? An exponential function that is growth has a that is positive, so a is greater than 0, and b will be greater than 1. Exponential decay will have a greater than 0, but b is going to be less than 1 and greater than 0. If I asked you to compare exponential growth and decay, can you see how they both have a is greater than 0? Because a is greater than 0 for both, I'm going to flip back here. Because a is greater than both, that will have both equations, decay and growth, will both be above the x-axis, okay? Growth rises up to the right, decay rises up to the left. I'm going to try to trick you on Monday's checkpoint quiz. So it's not only that do you understand what b has to be, but for it to be growth or decay, a has to be positive. So is the a positive in example A? Now some students are going to go, how do you know? Because you don't see a number there. What number is hiding? So a is positive. B is between. If you didn't know that, you could go 1 divided by 5 on a graphing calculator. It's a decimal between 0 and 1. So because 1/5 is between 0 and 1, this is exponential decay. B is an example of exponential growth because a is positive and b is greater than 1. C is an example of exponential growth again because a is positive and b is greater than 1. Please write the word neither for D. I want you and your partner in 30 seconds to write down two equations. One that looks like it's going to be exponential growth, one that looks like it's exponential decay, but actually it's neither. And what would cause it to not be growth or decay? If the a was negative. So write an example that would trick students that appears to be exponential growth, but it's not. It's just an exponential function. And likewise, write one that appears to be exponential decay, but in fact, it's only exponential. Go ahead, 30 seconds, go, with your partner. Okay, my first one is an example of only exponential. I think it's going to trick students on a quiz. They're going to assume it's growth, but because A is negative, it's neither. And again here, this is my example of trying to trick students of it becoming exponential decay, but really it's neither. Okay, go on to number 8. So if you were not aware of this, I grew up on a farm in Minnesota until I was like 10 years old. So I grew up, like, I had my own horse when I was like 3 years old. So I grew up with horses and cows and goats. And, you know, I was very rural. I went hunting with my father and things like that. So this definitely applies to when I was 10 years old, we moved off the farm and into a small town of 150 people. 150, does that seem small? Yeah. Okay, so you're going to read number 8. One of you reads it to, I heard you, Henry, that's right. I got big ears for a reason. Okay, one of you is going to turn to your partner and read number 8 aloud, and then we're going to create an equation that models this information. In my opinion, I don't think this is hard math, but I think that if you don't pay attention to details, you struggle. So here's what we're going to do. We're going to go slowly through this. Do you see 2 large values? Yeah. One is associated with a time period that is the earliest. So I'm going to write initial right here. The time period or the date that is the earliest will be your initial value. And your initial value always goes in the A position. The second value of 80,000 is your final outcome for this problem. So here is your final outcome. Within this problem, you see nothing that describes an exact growth rate. Like we can see the number of farms in Minnesota are going down, but it doesn't tell you like a percentage that represents that. So I'm going to put a lowercase b in this position. We generally put an X here. X represents the number of years since 1983. So I look at the 2 years and I subtract. The difference from 1998 to 1993 is how many years? 15. Now if I asked you to solve this, you're going to do PEMDAS backwards. So you start at the bottom. On the side with the variable, there's nothing that I can add or subtract to eliminate a value. There is something, so after adding and subtracting comes multiplying and dividing. I can divide this value to both sides. We don't want to round and then have to round again if it's possible to leave something as a fraction. So let's start by taking 80,000 and dividing it by 102,000. Please do that. So we can see it. Okay, so I have a decimal, but it's ongoing, irrational, it almost appears. It appears that way, but can I put it back into fraction? I can. Okay, so I'm going to rewrite this as a reduced fraction of 40 over 51. In the previous unit, you learned that if you want to eliminate an exponent, you raise it to the reciprocal. So placing parentheses around both sides, I'm going to raise it to 1 over 15. And at this time, I'm solving for that growth rate. By the way, make a prediction. If something is exponential growth, it's going up, right? It's greater than 1. Your b value is greater than 1. If your growth rate says something is declining, it's between 0 and 1. What do you think this will be? Fraction. Greater than 1, or will it be between 0 and 1? What's happening to the farms in Minnesota? They're decreasing. Okay, so put in parentheses 40 divided by 51. Now raise it to, it has to be in parentheses, 1 over 15. And we are going to round this because we can't put it back into a fraction. I've already tried. So what do you round to? Well, the further you round, like if you do a thousandths versus hundredth, the more accurate your final answers will be. So I'm going to round this to the nearest thousands. So 0.98, and this is going to round to a 4. Okay, gonna rewrite this. Now rewrite a function. So y equals, here's your initial value. Here's your growth rate. So when you rewrite your equation, you go back to an x and a y. Keeping the a and the b value that you've calculated. That is writing, yes, we've just created an equation that models this information. So now write that down here. And for part B, it says, suppose the number of farms in Minnesota continues to decrease at the same rate. Estimate the number of farms in 2010. So most students are going to want to plug in 2010 here. But if you look up above, it says that it has to be in terms, X is in terms of the numbers since 1983. So 2010 minus 1983 is 27. So I'm going to replace X with 27. And there's not really any work I have to do now on paper. I can grab a calculator, type in 0.984, raise it to the 27th, press enter and take it times the initial value. And so we can say approximately is the key, approximately 65,988 farms are remaining in Minnesota in 2010. My previous period, I gave them 3 minutes to do the next problem, which is the same concept, and not one student was able to get done in 3 minutes, so I'm going to challenge you with 5 minutes. Somebody's going to have to read the problem. This will be number 10 and 11, and then when I ask you to come back as a group, even if you're not done, I'm going to ask that you stop working and we check our answers together. 5 minutes, somebody starts reading, begin. You're doing the exact same way we did the last problem. Does she like it so far? She does not. Make sure you're working together. Minutes remaining. Miguel, you doing okay? Okay. You do both parts. Yep, the top one and the bottom, right below it.
That's a good number.
you say, dear?
I'm going to do 10 and 11.
You do both problems.
10 and 11?
Mm-hmm. Thanks, Martha. How many of you would like another minute? Another minute right now. Okay, I will give you close to the full 5 minutes. Thank you for working so hard. We'll go 30 more seconds. So you were doing, nope, just 10 and 11. Thank you for asking, Miguel. Just for time reasons, I'm going to stop you. I'm stopping you just a couple seconds short here. Even if you're not done, can you look up above? Let's go back really quick and look at 8 and 9. Is A positive or negative? Positive, okay. And is B greater than 1 or between 0 and 1? So is this an example of exponential growth or decay or neither? Decay, positive and between 0 and 1. Let's do the next one, and then we'll analyze it to see if it falls into exponential growth or decay. So I'm going to try to do this a little bit faster here, just to save some time. If you see a mistake made, or if you have any questions, stop me. So I can see between the two dates, this is the earliest one. So this is going to be my initial amount, and this is going to be my end amount. Okay, there is no number that represents a growth rate, and the dates from 2000 back to 1990 is a difference of 10. How many people initially set it up correct? Almost 100%, so I'm solving for B. I'm going to start by dividing, and I'm going to see, does that reduce nicely? No? 109, 4, 7, 8. Do you guys have this as a fraction? Okay, again, it's important not to write the decimal down and to estimate and then have to estimate again. So I'm going to come off to the side. Okay, and now I'm going to raise both sides to the 1/10. And now I will probably have to estimate. So if I'm going to take this value and I'm going to raise it to the reciprocal of 10, which is 1/10. And now I'm going to round this to B. B is approximately 1.354. So in writing my equation, I have y equals your initial value times a B value raised to the x. No penalty for wrong answers. How many of you had this equation? Hands up high. Great job. Okay, with this, now I want to check and estimate. So in number 10, it says to estimate the number of cellular phone subscribers in the United States, assuming that we continue to increase at the same rate in 2010. So most students in the past, when I see a mistake, they want to type in 2010 for x. Remember, it goes back to your initial year. So the difference from 2010 back to 1990 is 20. So I'm taking 1.354, raising it to the 20, and taking it times that initial amount. How many of you have this number? Really large number. Okay, so 2, 2, 6, 5, 9. All right, going on to a new concept. Oh, let me go back really quick. Let's talk about this really quick. A is positive, B is greater than 1. Example of exponential growth or decay. Growth. Okay, write this down, go back up above, and I'm just going to give you a few examples, and we'll go more in depth later on in this unit. Here are some applications to exponential growth and decay. It's often used in biology, physics. Write these down, please. These are examples where you're often going to see applications. Biology, physics, economics, finance, and computer technology. Biology, physics, economics, finance, and computer technology. 1/3 of your homework is going to come from problems like number 12. And in the past, students like these because they're just procedural type problems. You're going to be relying on the table that is to the left of Jesus. Everybody look at that table? That's what we're going to be looking at. Okay, so do not write down what I'm going to write down right now, but I want to compare it to something that you've done previously. Do not write this down. Okay, if I asked you to solve this, and I just made this up, it doesn't mean it's going to work. If I asked you to solve this, hopefully at this point in your math career, you'd go, okay, I want to find a common denominator. So let's make this 12, make this 12, and now I need an x. This needs an x, and x, and x, and x. Now we have 12x, 12x, 12x. I cancel out the bottom, I solve the top. Is everybody comfortable with that? Okay, that's the same type of concept we're going to do here. Assuming that there's no numbers like a +5 in front or a -6 in back, assuming we have a base raised to something equals another number, our goal is to get the same base. So find 81 over there, please. And you want to find 81 where it relates to the base of 3. Why am I doing that? Look back up to the board, please. Does everybody see how I have a base of 3 here? Okay, find 81. How could I rewrite 81 keeping the same value of 81 but having a base of 3? So ask yourself, 3 to what power equals 81? Anyone?
4.
Okay, you're doing the same thing in your paper. 3 to the 4th equals 3 to the 2x plus 1. As soon as the bases are the same, just like when we had common denominators, we're going to cross out the bases and we bring down exactly what we see in the exponent position. Subtract 1 from both sides. 2x equals 3. Divide both sides by 2, and x equals 3/2, which is the same as 1.5. Whether you write 1.5 or you write 3/2 are the same thing. We have to go back and check. Grab your calculator, please. So now I'm going to substitute in, because I think it's easier to substitute in decimals. I'm going to use 1.5. Please plug it in the same way that I am. 3 caret key, parentheses. 2, and now I'm going to substitute 1.5 in for x, so parentheses 1.5 and parentheses, plus 1, and now end parentheses again. When I press enter, if it equals 81, that means that answer checks. We're good to go. So again, whether you put 3/2 or 1.5, you're good. Flip to the next page. Please look up at the chart. Find the number 4 and the number 8 that are in the same line. What base number do they both relate to? 2. How can I rewrite 4? 2 squared, good. And how can I rewrite 8? 2 to the 3rd, great job. I'll let you write this down. Okay, so how does this work? Here's the first part is when I see students do this problem, rarely do they make a mistake on this type of part. So we get to cross out the base and they see 4x on the left. Where the mistakes often come are on the right-hand side. And it's because students forget that this 3 has to be distributed to everything in the parentheses. Okay, I'm going to solve it. I'm going to subtract 3x, divide by 1, x equals -3. Instead of plugging this in on your calculator, I'd like you just to watch me do it. So I'm going to go 4 raised 2, and I know that -3, which is my answer, times 2. Again, I know that -3 times 2 is -6. How many of you, when you see the E, does it confuse you? Okay, so this is scientific notation. It says because it's negative, I'm going to take the decimal and move it 4 places to the left. So this becomes, on the left-hand side, 0.000244 approximately, because I moved the decimal 4 places to the left. 1, 2, 3, 4. And the open positions receive zeros. On the right-hand side, 8 raised to the negative 3 minus 1. I have the exact same answer. I move it 4 places to the left, and it will be 0.000244. This checks off. It works. Can you raise your hand if you understood how I did that problem and checked? I know the checking part is often confusing. Okay, inequalities. Luis, can you tell me when's the only time we flip an inequality symbol? Dividing by what?
Negative.
Or doing what else by negative? So whenever you multiply or divide by negative, think you're going to flip the symbol. Okay, we're looking for a value of x that would allow the left side to be greater than the right side. Okay, well, let's just make this easy on ourselves. Let's think of this right now as kind of like an equal sign. And we'll come back and we'll make sure if needed we can flip it. So look over there on the chart. Forget about it being 1 over 256. I want you to identify the line that has a 4 and a 256. Find the line? Okay, so 4 does not have to be rewritten. And when I first just think of 256, I forget about 1 over it. How do I write 4? So 4 to what power is equal to 256? This equals 256, but notice it wasn't happy, so it went to the bottom. We represent that with a negative sign. Okay, so let's cancel out the 4s. And again, I'm thinking of this right now as an equal sign. We're going to go back. We'll see if we ever had to flip this. I'm going to add 1 to the opposite side. Divide by 3. And here is actually, if we go back and we replace the equal sign with really what it was, here is where there's confusion every single year. Students say, yes, you have to flip it, and the reason is because your final answer is negative. Students say, yes, you have to flip it because here we're dividing with a negative. And other students say, no, you don't flip it because the bottom number is a negative. Turn to your partner. Which one is right? The answer is you do not flip it because we are only concerned with what number we are dividing by. Since it's positive, we don't flip it. So x is greater than negative 1. This is if you choose any number where x is greater than negative 1, it will make this statement true. And in fact, if we had x equals negative 1, the left side would equal the right side. That's what it says. So let's choose a number that is greater than negative 1. What's the easiest number to choose? 0. Okay, let's plug it in. So I know 3 times 0 is 0, and 0 minus 1 is negative 1. So 4 to the negative 1. And in this case, I'm not going to change it back into a fraction because I think it's easier to compare the value of decimals. Now I'm going to take 1 divided by 256, and I want to evaluate, is the left side greater than the right side? It is, so this answer is true. If you put negative 1, if we substitute negative 1, the left side would have equaled the right-hand side. Good question. Okay, go down to 15. One person reads it, and you write down an example, each of you, and you have 30 seconds to do that. Go. Five seconds remaining. You're writing down the equation. Aurelie, please give me your example. Say it again, please. I'm sorry.
Y equals 1/6 x.
Do you guys agree?
Yeah.
Okay. How could, turn to your partner. I'm not going to ask you for an example. I want you to be aware. How can we make this exponential, but it not be decay? Turn to your partner. Go. What is the a right now? Hidden 1. What if we made it a negative 1? Would it be decay then? Because the a is no longer positive. Okay, you're going to go down to 16. A, B, and C. One of them is linear, one is quadratic, one is exponential. You're going to do this in 20 seconds. Decide which one is linear, quadratic, and exponential. And the key is with your partner, how do you identify it? Like, how do you know? 20 seconds, go. Okay, you ready? So part A. Part A is quadratic, and there's one reason you know that, and that is because the degree is a 2. Likewise, we know part C is linear because the degree is 1. And we know part B is exponential because the exponent is a variable. By the way, is B an example of growth, decay, or neither? Decay and why? There's 2 reasons. B is between 0 and 1, and A is positive. Go down to 17 for A, B, and C. In the past, students would naturally grab a calculator, they'd graph it in a graph calculator, and then they'd try to match it. That's the long way. You can do this problem total in less than 30 seconds. And this is all based on understanding what we wrote down at the very beginning. So look at this. You ready? I want you in 5 seconds for the A, B, and C equation to write down what is the y-intercept for each one. So like I'm going to write down 0, 1. Do that for the next 2. Ready? Get set, go. So one of them stands out as having a y-intercept of 2, correct? Okay, look down below. Which one has a y-intercept of 2? So I'm just going to draw an arrow from this equation to A. And notice, by the way, is that growth or decay? Okay, growth goes up to the right. Growth goes up to the right. Now let's look. So I have little b and little b and c left to match with A and B. They both have the same y-intercept. They both have positive A, so they're above the x-axis. But here, this is an example of growth. This is an example of decay. Would we classify this graph as growth or decay since it goes up to the left? Decay. And since it goes up to the right, this is growth. To save time, please look down at number 18. You and your partner will choose one of these graphs, little a, little b, or little c, doesn't matter which one, and you're going to identify the domain, the range, and the end behavior in 45 seconds. Go. Okay, you're going to want to keep these notes. Please pass back the homework. Initially, put your first and last name on it. Then turn to the first problems. I'm going to go through a couple with you. We need to go fast. Just to save time, when I say go, you'll have 20 seconds to put a capital D, a capital G, or a capital N representing growth, decay, or neither next to 1 through 4. Does anybody need me to repeat the directions? You're going to put a capital G to save time, a capital D, or a capital N for neither. On 1 through 4, 20 seconds, go. 1, 2. 1 through 4. Do them. Five seconds remaining. Okay, hands up if you're done. Okay, now read the directions to yourself for number 5. Go. I want you to turn and find the very beginning of our notes today, which would be number 6 in your notes. Amy, is number 5 an example of exponential growth, decay, or neither?
Growth.
Why is it growth?
Because
There's 2 reasons.
because the A is positive and the B is greater than 1.
A is greater than 0, B is greater than 1. We know that's exponential growth, okay? Make a really small graph. Exponential growth, because A is on positive, I know it's above the x-axis. Growth goes up to the right. Thank you, Amy. So domain, looking at where you took notes today. Hey, Zeus, the domain for all exponential functions is what? Thank you. The range for this picture, Aldo, what is the range for the graph we have? Thank you. Asymptote. Alexis, asymptotes for all exponential functions, assuming we have not shifted them, is what? What? 0. Y equals 0. Thank you. And the y-intercept for this problem is what, Jacob? You can't just say 3, but you got the right idea. 0, 3. Can you do a thumbs up or thumbs down if you understood that? Okay, so your goal right now is to finish 6, 7, and 8. Go.